Hello YouTube and welcome to the second part of the Python tutorial for Blender. If you haven't already watched the first part, I recommend you do, because it will be going over the very basics of what we need to know for the next video and the rest of the series. First, you have to be in Blender Game View. Select this from the drop down here, or press Ctrl right. Press Ctrl right to get into the Game Logic view. This will enable you to see all of the things you'll need for scripting Game Logic, and then select Blender Game from the drop down. Always a good start. Right, create a new text file, or use the one from the previous example. Connecting always to a Python controller on the first default cube. Set it to the name in the drop down, text in this case, or we will call it example.py, or sorry, functions.py for continuity, and click into the main window. You'll be presented with the default window, and that's where we're going to start from. I won't go over this in the next tutorial. I'll assume you've already seen the last two, and therefore you will understand what we're going through. So you should have already looked at data structures and variables, and we did briefly look through the for statement and the if statement. So as a quick recap, the for statement is an iterator. It iterates over a list or a dictionary or any other iteratable object. That can be a string. It can iterate over each letter in the string or each character, a list for each value. A dictionary by default will be each key unless you tell it otherwise, and you can have it iterate through a range of numbers as well. Let's make an example. Let's create a list of numbers from 1 to 10. And we'll make it iterate through each of those numbers, and if that number is even, it will divide by 2. It will print yes to the console. Or let's make it even easier. If that number is more than 4, it will print more than 4 to the console for easiness. So select the Toggle System Console from the Help menu on Windows. If you're on Mac and you can't see the console, you will have to start Blender from the console. If you don't know how to do that, the easiest way is to right click or command or control click the Blender the Blender app, open it, go into Mac OS X. If you're not in, go to Package Contents, Mac OS X, and then you will see the Blender console looking thing. It's a bit of a console icon, a bit like this. And you run it from there. Drag this to the right hand side and you're set. I'm going to make this slightly wider for you. So let's make a list. List of numbers equals square bracket 1, 2, 3, and so on till you get to 10. Now make a for statement, which, if you don't remember already, is just for, then a variable that will define each iteration. Let's call it number. In is a keyword, and then the name of the list or the iterator, which will be list of numbers, and a colon to show that it's a process. Now we want to check if each number is more or less than 4. So how do we do this? Well, it's very simple. Use the if statement in combination with, let me just pause this video, it's being processed. Use the if statement in combination with the number and a comparison. So let's use the word if number, that's what we want to compare, the operator more than, then let's say we're going to type in 4, so if the number is more than 4, colon to show that it's a process, we will print using the print statement with the parentheses, 2 quote marks or asterisks, no, apostrophes, it's very late here, for me anyway, and then you will say more than 4. However, if it's not more than 4, we'd like to print that as well. So we could use another if statement and write if number is less than 4, or if number is not more than 4. So I'll show you this first. if number not more than 4. This not keyword says that it'll do the opposite. It checks for the opposite of this condition without the not statement. So the opposite of this condition. So if this is true, it will return false. You can put this not statement anywhere. You can put it before or after the number. I tend to stick it before the number because it makes more sense. And you have it print less than 4 or less than equal to, because you'll notice that 4 is not more than 4, but it is equal to 4. 2, 4, and finish off the statement. And if we print this, you'll see it says less than equal to 4 times, and then 7 times it says more than 4. So what should we do now? Yes, we shall look at the else keyword or statement. Now, else is essentially the same as this statement here. It activates on the condition that this is for false. So if this statement, if number is more than 4, says no, number is not more than 4, instead of typing out another if statement, you can use else, and else will decide that because number is not more than 4, it will run their statement instead. So just type else, and you'll see the same happens here. This is essentially a bit like if, otherwise, if or else. So that's the else keyword. However, you may notice that if I use 2 if statements to do this, if number is more than 5, you'll see that this statement is a mix of statements in the console. So if we wanted to run something, if this was false, this first condition, you would use else. But what if we wanted to check if something was another condition whilst using the else statement? Let's say we wanted to see if number was more than 6 if it was less than 2 if it wasn't more than 4. You could use another if statement underneath the else. If number is less than 2, or you can use elif. And you'll notice it's essentially the same as else and an if combined. If this returns false, it will then execute this condition. So we'll put less than 2 and not more than 4 will be this identifier. So the first number is less than 2 because it's 1. The second one is not because it's 2, and so on. That's the elif, else, and if statements. So as a quick recap, I'll show you them here. You have if, first comparison, operator, last comparison, and you can use more than, less than, equal to, and equal to you must use 2 equals because you don't want to set the variable, you want to check the variable. This is why it's very important in coding languages you know when to use them. You can also use not equal to with an exclamation mark, and you cannot just use the plain less or more than. But that's not all. In an if statement, you can do any operators as long as you're using a condition to compare. So I could do first comparison, or for this example, if number plus 12 is less than 14 rather, you can still do that. However, there's something else you can do with if statements because they're very magical. You can do more than one comparison at the same time. You could see if the number was more than 2 and you'll see it's gone purple, so it's a keyword, number is less than 10 or less than 8. Now, it's good practice to leave these in parentheses because later on you may have statements which I'll call it bleed out, when they will actually not work as you expect them to. So always use brackets for the conditions. And this will check, is the number more than 2, which is 3, 4, 5, 6, 7, 8, 9, 10, and is it less than 8, which basically leaves you with 3, 4, 5, 6, and 7. If you print number, no speech marks because we're printing a variable, you'll see it says 3, 4, 5, 6, 7. So, what if you wanted to see if it was either more than 2 or less than 8? You'd use the OR statement, and you'd print the number, and you'll see a larger range of numbers. Every single number, in fact. If we do less than 2 or more than 6, for a better example, you'll see only 1, 7, 8, 9, 10. This is just simple maths. So this is the if statement. What else can you use? Well, if statements are used for comparing variables, and they're used in sort of conditions. For statements are good for iteration, using the same piece of code on a list or an iterator. But there are other things we want to use in Python. For example, if I have a piece of code that I use regularly throughout a script, rather than having to copy and paste or write it out each time and change the variables, you can use that same piece of code from a function. What are functions? Well, if you think about functions in maths and graphing, you change the data within the parentheses and it will return a different result following a predefined formula. If you don't understand what that means, then we'll continue on and I'll show you an example. First things first, you need to know how to define a function. This confused me when I first started using Python, which is why we're going to go over it quite carefully at the moment. To define a function, use def keyword, short for define. You must then leave a space and name the function. You can use any name you like as long as there are no spaces within it. Let's call it addition. Now, functions accept keywords or variables. They allow you to send data to them and execute special conditions upon receiving them. Therefore, you can add two numbers by sending them as keywords. So, in order to define the keywords, you don't have to use them, but a function requires you to have parentheses which would indicate you would use keywords. If you were to add them, you would add them within the parentheses. So we're going to use some keywords. Let's add two numbers together. Anything you write within these parentheses will become variables once you call the function. So they don't have to exist already, but they have to be something in word form that you can recognize. So call it number1, comma, number2. Now what does a comma do? As we've already discussed, commas are used for list objects or list unpacking essentially. You can get more than one value from a list by assigning each value to the sequence with the comma. So if we add two keywords to the addition function, it will take the first keyword as number1 and the second as number2. So let's have our addition function add two numbers together. So let's have answer, a variable, indented because of the colon, because this is a process, equals number1 plus number2. If I could type this, it would help. Now that's good. How do we return the answer? Because this is essentially like sending an email to someone asking them to add two numbers together. But if they don't reply with the email, what use is it? Nothing. So we have to use a return keyword telling it to send back the data. The return keyword doesn't have to have any arguments or variables, but if you give it variables, it will return that data from the function. So you'll understand this later, but for now, type return answer. This will return the variable answer, which we've just defined here as the two numbers added together. So how do we use this function? Because this is a working function. Let's set a variable as the answer. How do we do that? Well, let's call mySum, a variable, equals operator, addition. This is calling the addition function because we add parentheses, 2, 4. You'll notice that we've used direct numbers here because we can, although you could use variables and define them above. This addition word calls the addition function, and the numbers after it are the same as the numbers after it in the definition. Now, if we press P, you won't see anything in the console because we haven't told it to print anything. If we were to do print MySum, you would see 6, 2 plus 4. You can also do a print statement within the function. You can execute any code within a function. And answer is, and as you remembered, you can add a comma, answer. This will print answer is and the variable answer. And you'll see answer is 6, and it prints 6 here as well. So this is the basics of a function. Functions can return more than one variable in the same way that we've used them before. To use more than one variable, you add a comma and the next variable. So let's return answer and answer times 2 using the multiply operator and 2. Now if we print MySum, you'll see that you'll get 6 and 12 in a tuple, which is a bit like a list but not quite. In order to set these as variables, you have two options. Either do ans1 equals MySum square bracket 0. This will unpack the first value of MySum as answer 1 because remember Python starts counting at 0. And the same for answer 2 with a 1, or we could set answer 1 comma answer 2 equals MySum, and then print answer 1 print answer 2, and you'll see 6 and 12 because they've unpacked. This returns 2 variables, and this unpacks 2 more variables as those same 2 variables. Very simple stuff really, but once you get your head around it, it's very useful. This can be used for large blocks of code if you're shortening them. For example, a quadratic solver, or maybe finding the square root of a number times by pi multiplied by the square root of 56. I don't know, anything you want to do really. They're useful when repeating large blocks of code repeatedly throughout the Python file. So this is a function. Now, what else can you use? Classes are something else that's used in Python. Classes are data objects. Object-oriented programming uses objects. Essentially what this means is that there are special coded structures which have names, they have attributes or properties which you can set and read and remove, and they can have methods. Now this only makes sense after you know what they do. It's a bit like having a property on a game object using properties. This game object is an object and it has now a property. How this actually works is different, but this is a good analogy. You can set the property name, you can set its value, and you can remove it entirely. You can also set the object's position. You could rotate the object, and of course you can delete the object, but we're not going to do that. So this is essentially what a class is. It's a Python object. But Python isn't purely object orientated, but it's an element of object orientation, which is quite useful. So these forms of data structures are useful when you're trying to create custom applications or attributes. They're not always needed, but they are nice because they make sense and they look nice to the human eye. You can set their properties rather than having to set list numbers, and it gets all confusing in big bits of code. Using a class, an instance of a class can have words as variables. For example, class dot name equals Bob, rather than class square bracket 0 and using a list. So how do classes work? Well, classes all have a main instance, or the parent. What this means is you create a definition of what the class structure works like, and you can set its default values. Then you can access this class as an instance, as you do when you add game objects within the game engine. It adds an instance of them, not the actual object. It's a copy, and so that means when you change a variable on the copy, it does not change the main variable on the official or original class. Let's get cracking on this. To define a class, type class, class, then the name of the class, as we did with the Python functions, my class. Let's do an example, actually, employee. I think I've seen an example like this before. You don't have to use, you don't need to use parentheses for this, and this will create a class called employee. Now, to store attributes on classes, you need to access a reference to the class itself. Now, Python does this in a very peculiar way. Essentially, when you call a class as an instance, it will initiate itself from the main parent. To do this, it needs to know who it is, because the class doesn't actually know what it is itself within the script unless you tell it. So when you call it as its first instance, it will call an init function if it exists. So for now, type def underscore underscore init underscore underscore, you need two parentheses colon. Within the parentheses, type self. This is the main structure you need. This means when you call the class, it will register itself to the variable self. I won't explain to you why this works, but this is how it always works. You can change the variable name as long as you use that same name throughout the script. And you can set variables to self.name equals hello, and so on. But for our example, we want to create new employees using this structure. So to pass variables or arguments to a class, you have to add them in the init. You can add them in the init function, because we're going to only do this once. So this will become clear later. But add a comma, name. Self.name equals name. Self.job equals job, and define job up here. That works. Now, let's see how this works. To call an instance of a class, first type the class name or create a variable register, because we have a register of employees as we would in a business, equals employee, two parentheses. Why do you have these parentheses? These call the initiation of a class. They create the instance of a class. If you didn't use the parentheses, you'd be referring to this actual bit of Python here, and it gets messy. So you create an instance using these two parentheses. But we've already defined name and job as arguments in the init. This init only occurs when you type this bit of code, and you don't use this code more than once. You start using register, and I'll show you why in a minute. So we need to tell it the name and the job because we've passed these as arguments. Self is already given by this actual bit of code itself. It refers to itself. So in here, type James, and we'll make him a engineer. Now, once you do this, this will set a class instance as a variable register, and you can access these two variables here through the register variable. So you can do print register.name, and you should see James. Now, this gets interesting because you can do it twice. Let's have, let's make register a list. Delete this statement so you don't get confused. And we're going to have a list of every employee. So, let's have employee 1 or worker 1, not to get confused. Worker 2 equals employee, and we'll have him called Mike, and he'll be a desk jockey. Don't know if that's the right word, but that's what I'm going to use. And this creates an instance of the employee class and sets their names on each variable. We add these to register, and that will add them to the workers list. Now, just to show you what this looks like, if you print the register list, you'll see its values, but they're not what you'd expect. you see weird bits of Python. This basically tells you it's an object because classes are objects, and it's an identifier. This tells you it's the main part of the class. Don't worry about that for now. So let's take the first item, register 0, and print their name. Then let's print their job, and that should tell you that this guy is an engineer. This is a class. But you can also have functions within classes. Let's make a function called fire. And this will fire him. You must type self within here because it gets its own instance as a reference called reference to the first argument. So this will tell it who it is. You have to use this if you've defined it up here. And then we'll have him. We shouldn't have to pass an argument to this. We'll make it just fire himself. So register, or let's just have it for now. Print I'm fired, unhappy face. And make sure you haven't, like me, put a colon and then an apostrophe and an apostrophe, or a colon and a colon. Sorry, an apostrophe and an apostrophe, or a speech mark and a speech mark, because they will get confused. Now let's have register the first employee fire himself. And if you see this, he will print I'm fired. And to make it more interesting, we can make it tell who's been fired. Self.name, comma, speech mark, has been fired. And let's make it a bit more like Alan Sugar and put an exclamation mark. And James has been fired is printed in the console. You should now realise that this full stop accesses an attribute or a property. Now this attribute can be anything from a function to a variable. So we can access their name through the .name, but because fire is a function, it's already created. Anything within class is created upon the class instance. So that's all well and good. That's essentially all you need to know about classes. We'll come across them later on in a more in-depth tutorial, but remember this is how the structure works. So that's classes, and you've looked at if statements, and you've also looked at for statements. The only thing you need to look at now is deleting variables for this tutorial. I rarely delete variables, but you may want to if you're creating a certain type of script. You have to be careful about deleting variables, because if they're accessed later on in the script and they don't exist, they will throw up an error. Let's create an example. Delete all this code, or save it if you like, and create variable equals 1. Oh, it's annoying it does this, hold on. Now, if we print variable, we'll see 1 in the console, but if we type del variable, short for delete, it throws up an error because you haven't defined it, because you've already removed it. Put the print statement in before and you'll see it says 1, and then 1 is gone. This deletes any Python object only whilst you're running the Python in-game engine. Del. And this pretty much concludes the tutorial. I'm going to keep it short because I've covered quite a lot in two tutorials, so I think what would be best is anyone who has any questions or anything I need to go over again, if you leave me a comment on the YouTube channel, double clicking the video if you're on the website, or actually going to youtube.com and looking at my username, agoose77, and you'll find it in the tutorials category. And then leave me a comment and tell me what's good and what's bad. This one's been quite rushed. I'm in the middle of my exams, and I thought I would get one out just to keep you guys interested and have a bit of fun. So I'm going to keep them about half an hour for now. They're working quite well around half an hour. It can get boring, but it's best if you watch them through. And yes, if there's anything you guys don't understand from other tutorials I can help you with, leave me a comment and I'll write you a supplementary tutorial. That's about it.